All right, so now we're going to talk about the power of a quotient. So similar to the power of a product, let's say I'm just going to give you the rule. Let's say you have A over B to some outer exponent there. That's going to equal A to the nth over B to the nth. So you're bringing the exponent into each base, okay? All right, that's the rule. So let's see what we have here. Simplify each of the following quotients as much as possible using the power of a quotient rule. Write answers with positive exponents. Okay, so for this first one, it's going to be, let's see if I can make these a little bigger. 4 cubed, so think of it like 4 to the first power, but it's going to be 4 cubed, I'll have to figure that out, and then z to the 33, right? So it's 3 times that 11. And 4 cubed is 4 times 4 times 4, that's 64. So I would multiply the 4 cubed out, it's not a big number. So 64 over z to the 33rd power. Okay, so the next one, it's p to the first power, so it's going to be p to the 6th, because you're going 6 times 1, over q to the 18th. So that's a fun problem. Hope for one of those on the test. Okay, and again, you're going 6 times that 3 down there. Okay, now what are you going to do with negative 1 to the 27th power? We'll talk about that in a minute. Okay, over t, okay, now you got to go 27 times 2, that's 54. Now you're not going to leave it negative 1 to the 27th, because negative 1 times negative 1, 1 times 1 times 1, it's just going to be some kind of 1. It's either a negative 1 or it's a positive 1. Well, think about having 27 of those negative 1s. That's an odd number, right? So it's going to be negative. So my answer here is going to be negative 1 over t to the 54th. And so it's probably better to think about that rather than put it in a calculator. If you were going to put it in a calculator, you'd put that whole thing in the calculator, negative 1 with the parentheses to the 27th, because if it had been to the 28th, see, that's an even exponent, so now it would have been a positive 1, okay? So you got to think, kind of think along those lines. But this one, negative 1 to the 27th, that's negative 1. So I get negative 1 over t to the 54th power. Okay, so we have a couple more. All right, so I've got 4 times the 3, 4 times the negative 2. This is one way to do it. And again, this is one of those problems where, you could do it a different way. You could take care of the negative exponent first, but I didn't. I just brought in the outer exponent. So that's that power to a power thing. We had 2 different bases, j and k. So 3 times 4, 12, negative 2 times 4, negative 8. But I can't leave the negative exponent, so I'm going to change it to j to the 12th over k to the 8th. So when you put that k to the 8th in the bottom, that makes that exponent positive now, okay? So a negative exponent's all about location, location, location. So if it's a negative exponent, you got to move it down, okay? All right, and let's see what we have here. Well, they're both negative, right? Okay, so I'm just going to multiply m to the negative 6, n to the negative 6, because negative 2 times 3, that's negative 6. Okay, they're both negative exponents, so they both got to move. I always say they're moving downtown because they weren't happy being in the numerator, so they had to move downtown. I don't know if that helps. Okay, but that's how it works. So the m to the negative 6 goes in the bottom. Now it's m to the positive 6. The n to the negative 6 goes to the bottom. Now it's n to the positive 6. Why do I have to have the 1? I have to have something uptown, otherwise it's not going to look like they're in the denominator, okay? So there's the answer. You need that 1 in the numerator. All right.